Hello everyone, now we are solving the set C of my first internal paper of the subject computer oriented numerical method. Now the first question is find the output of x square minus x minus 1 is equals to 0 using Newton-Raphson method. Correct up to 4 place of decimal. So we are started the solution. So here are the solution of the question number 1. Choose an initial guess x naught is equals to 1. We are putting the x naught is equals to 1 in this equation x square minus x minus 1, so we get the minus 1, and again and the differentiation of f dash x is 2x minus 1, and put the value of x in this equation, so we get the 1. Now applying Newton-Raphson formula, and first iteration is x1 is equals to x naught minus f of x by f dash x is equals to, we are putting the value of x in this formula and get 2. So by the second iteration we put the value of x1 in x2 and solving this equation, so we get 1.1666 approx value. Now the third iteration we are solving x3, we put the value of x2 in this and solve by this equation, and we get the answer is 1.6191. And our fourth iteration is x4 is equals to x3 minus f of x3 by f dash x3 is equals to, here we put the value of x3 in this, so we get the 1.6181. Now there is no specified, there is significant difference between x3 and x4. Now the root of x square minus x minus 1 is 1.6181, because x3 and x4 has the same value by the fourth place of decimal. So we stop the solution and we get the final answer is 1.6181. Now the question number 2 is write an algorithm for finding square root of 7 using fixed point iteration method. So the solution is, for square root of 7 will be x square is equals to 7. We can write it as x square minus 7 is equals to 0. So the f of x is x square minus 7 and the differentiation of f of x is 2x. Now we take out g of x is x minus f of x by f dash x. So we calculate the g of x. Now the g of x is equals to x minus x square minus 7 by 2x. After solving this, we get 1 by 2 in bracket x plus 7 by x. We can take the initial value x is equals to 0, x not equals to 0, then solve until the change between the iteration is less than predefined tolerance. So we start the algorithm. First we start, and second define the function f of x, then define function g of x which is obtained from f of x such that x is equals to g of x, and in module g dash x is less than 1. Now the fourth step, we choose initial guess x0, tolerance error e, and maximum iteration n. Now in the fifth step, initialize iteration counter step is equals to 1. In step 1, calculate x1 equals to g of x0, increment iteration counter by step is equals to step minus 1. In the at step, if step is greater than n, then print not convergent and go to 12, otherwise go to 10. Set x naught is equals to x1 for next iteration. If f of x1 is less than e, then go to step 6, otherwise go to step 11. Display x1 as root and stop the algorithm. Now we are solving the question number 3, which is give the stepwise output of Gauss elimination algorithm for this matrix. In Gauss elimination method, we create element 0 which is below to the diagonal. For creating upper triangle matrix, we perform some operations. Firstly, we perform operation on R2. R2 is R2 minus R1 divided by 10 multiplied by minus 6. In R3 minus R1 divided by 10 multiplied by 3, and R4 is equals to R4 minus R1 divided by 10 multiplied by 5. Now after applying this operation, we got this matrix. Again we are applying the operations. First we perform operation on row 3. So row 3 is equals to row 3 minus row 2 divided by 3.8 into 3.1, and R4 is R4 minus R1 divided by 3.8 into 5.5. Now the matrix we will see. Again we perform the operation on R4. R4 minus R3 divided by 2.45 multiplied by minus 2.35. After applying all the operation, we can see our upper triangular matrix. This we can create. Now equations will be 10x minus 7y plus 3z plus 5 is equals to 6. This is our first equation. And 3.8y plus 0.87 minus k is equals to 8.6 is our second equation. 2.45z plus 10.3k is equals to minus 6.62 is equals to this is our third equation. And 9.93k is equals to 1.01 is fourth equation. Now we can solve. We find the value of k is 1.017. Now put the value of k in equation number 3. After putting this value, we got the equation, and after solving this, we got the value of z is 6.9775, which is approx to 7. Putting the value of z in equation number 2, then we get the value of y, which is 1.42. Now put all the values in equation number 1. So we get value of x, which is minus 1.01, which is approx to 1. So the value we get here, x equals to 1, y equals to 1.43, z equals to 7, and k is equals to 1.017. Here are the some values we get in this matrix. Thank you.